So the next question that we are taking on is minimum depth of binary tree. This question is an easy tagged question and it has a successful submission rate of 49%, which I must admit is quite low compared to the tag it has that is easy. So anyways, the question is to find the minimum depth of binary tree. And what does the question mean by minimum depth? So a leaf is a node with no child, and we need to find a leaf at the minimum depth. So that is what the question is about. So the plan is to use breadth first search, and this problem can also be solved using depth first search, but the breadth first search is going to be more efficient, and we'll see how and why. So when we perform a breadth first search, as usual, we will be traversing in level order, and this is level 1, this is level 2, or you can call it in terms of height. So this is height and 1, height 2, and we are moving downwards. That is what is happening here. So the moment we reach a level where we find a node which is leaf, so we find like here this node is a leaf. We stop the traversal and we return height, and the height is 2, and that is the output. So the output is also 2, and that is how we are solving this problem. If we were to use depth first search, the approach would have been to visit all the leaves, store and compare like compare all the leaf heights and then choose the minimum among them. It is inefficient compared to breadth first search because in that you have to traverse the entire tree because you never know where the minimum depth lies. But in the breadth first search, we go from top to down, and like in this example, we didn't need to visit these nodes. We never had to visit these nodes. Uh, Only at the height 2 we found the leaf and we stopped right there. We didn't have to necessarily visit the entire tree and waste our time over there. So that is why we are using breadth first search, and that is what we are going to do. We are going to traverse in level, and the moment we find a node which is leaf on a level, we will return the height and break the entire code flow. So let's move on to our editor and make it work. So the idea is to perform the breadth first search traversal, and while traversing keep a track of the height, depth or level we are at, and if we find at that level, the moment we find a leaf, we just want to return the height and break the entire code flow. That is return. So height is equal to 0 while q. Let's define the node count variable which will count the number of nodes at each level or the current level we are at. We increment the height as usual after this, and before after this, that is before entering the node count loop. So this loop will continue as long as the node count is greater than 0, and everything that happens inside this loop is happening in the current level or in a certain level or height along the breadth. So I pop the node and check if there is a left child, and if there is, I'm going to append it to the queue. I'll check for the right child, and if there is one, I'll again append it to the queue. So this is simple breadth first search, and over here I will put the condition, that is if a node does not have a left child nor a right child. That is, we have encountered a leaf, right? A leaf is a node which does not have any children. So this is the condition for a leaf, and this is the first time that we are getting it, right? The very first time we encounter this condition, we want the entire code to shut down. That is return, and what we want to return is the height. And the last line of this loop should be, as always, node count minus equal to 1. And that is pretty much it. And this line, however, will never be executed, so I can simply remove it. And outside the breadth first search function, I want to check if our tree has a root. If it does not has one, I would simply return 0. Otherwise, I would return the output of the breadth first search function with argument root. I'll quickly run this code to check if there is a syntax error. No, it's fine. Let's submit it. And it's a successful submission as well. So that is it.